I'm sure it's awkward for everybody.
I know. All right, we should be live now.
All
I,
right. Go ahead,
uh,
Ravi. Why don't you start?
yeah.
I bet you have a spiel already. So.
Welcome everyone to another Data Science Club video. And so in today's session, we are planning to talk about checkpointing with DMTCP. It's a little different from our regular videos on the data science session, but I think checkpointing is essential, whether you are doing for any kind of coding, whether you're doing data science or it's just a C++ code that you're writing, or you're writing code in any language. Checkpointing is essential. Like we talked briefly at the end of our last video, uh, if you're working on an HPC environment, generally you have limits on how long your job can run.
Mhm.
And in those circumstances, it's essential for you to know about checkpointing so that you can just keep checkpointing your code and you don't lose out on all the work. So let's say the maximum time limit for you, or at least on Chihide, is 6 days, 6 hours, but your job runs for 7.5 days. So after 6 days, 6 hours, the job is going to be cancelled automatically because you ran out of time. That was the maximum that was allowed. By the time that you find that out, you are going to lose all the work that your code was doing for those 6 days, 6 hours. You don't want to
Mhm.
lose that. So that's where checkpointing comes in. You can checkpoint at, like, let's say the 6 day mark. And then when you restart your job restarts at that point. And then you have another 1.5 days for the second job, rather than being like, okay, I lost my entire last week because I thought that this would complete, but it didn't complete, and all this stuff. And and the other use cases are when if your system crashes for some reason. If you have checkpointed your code at periodical time, then you have a point to which you can go back to. It's a similar concept. If you guys run Windows has restore buttons for your operating system. It's a checkpointing system.
Yep.
Your Word kinda does checkpointing on its own a bit. Um, it does keep track of your files a little bit, and and a lot of tools already have some inbuilt checkpointing systems. uh, this is a way of showing how you can save the entire state of your running code, and with that I let William take away.
Yeah. So I was the one who kind of spearheaded well, I wouldn't say research, our research to us, right? Our
Yeah.
the research to us of this checkpointing concept. Um, so I'm just going to borrow from Gene Cooperman's lovely work on DMTCP. I forget already what that stands for, but that's okay. It's basically checkpointing with it's intended for single node jobs on HPCs, right? So if you've got some job you're running on one node on your HPC, then you can use this, and it's almost totally transparent. And basically, the way it works is, I'm going to skip all this stuff. It's as easy to use as you use this launch command, and you run it on your application, and then whenever you want to, you can manually checkpoint it, and then you can restart from the checkpoint file that was created, right? There's some more intricacies if you're interested. Like you can set an interval here in the launch command. Say I want it to checkpoint every 1,000 seconds, for example, or every hour, 3,600 seconds, whatever is relevant for your job, and it will wait till processes stop running. It gets to a point where it can stop your application. Say, okay, hold on just a second. I'm going to save your state to disk, and then you can start again. And that's basically what it does. It inserts a hook into your application at a reasonable spot and says, okay, right here, we're going to take a snapshot of the whole memory state, save it to disk, and then load it back. If you want to load it back up later with this restart, you can do so. And it's free open source, which is lovely. It's, as Gene says, it's 20 years old, so this has been needed for a long time, and it's still needed. So I'm almost a little embarrassed to say we're just finding out about it now. I mean, we both knew about the concept, but it's the first time we've ever. We were driven to this particular video by a couple of users on our HPC finally reaching the limits or pushing past the limits of our longest running time available. So we had to come up with some sort of solution. And so, yeah, like I was saying, checkpointing is the action of saving the state of a running process to an image file. So it's basically just saying, hey, what's in memory, of this application? And then it takes that and it literally just writes all the ones and zeros to disk. And then, and I apologize if this is, if you're way past this already, but, and then when you restart it, it just loads those right back into memory and says, okay, start like nothing ever happened.
Yeah.
And you can use it for process migration too. So you can, if you're running on one computer and they say, okay, you got to stop, you can't have access to this system anymore. We got to go, you got to use this system now. And you can take that save file, if it's, going to be a 100-day runtime or something, and move it over to another one and run it on that computer in principle. And then process replication for things like debugging, right? You can say, I want a checkpoint of this file at this time, and I've got one running over here and it crashed. So I'm going to take this one and copy it over and rerun it inside of a debugger, right? To find out maybe where or when it went wrong. And that's especially important if your computation is already finished. Say it's 1000th hour of runtime and you don't want to start it again just to debug it at this point. So
and that is an excellent use case. I mean, we generally have, so during our office hour sessions, whenever we are helping people debug their use cases, sometimes one of our biggest peeve is that generally users have a job script. I mean, it's not users' fault. It's basically how the code runs. It's basically like if they are running 4 steps in that and their job failed after the 4th step and the entire thing took a day, then to get to the 4th stage, they need to really, really again go back through the first 3 stages. And once you are trying to help someone face to face or trying to debug something, it's not an ideal condition where you have to again wait for a day to reach the stage where it's failing. So in those cases, yes, checkpointing would be super helpful. You can just start the last 5 minutes of the run, and whenever you think the 3rd stage has completed and the 4th stage started, you can just start from there. And that way you don't have to wait for everything to run again because everything has been checkpointed till that point.
Yeah, and I want to stress that it's not always the user's fault. It's often not the user's fault. It's just
mostly it's just how the code is, how the workflows are, and I think faults tend to find the spot where you'll have the most difficulty in finding them or replicating them.
Well, it's like in the 80s, 90s, and 00s, we built this mountain of code, but none of it was planned for what we're doing now with HPC, right? So we've got this big old mountain of code, and now we're having to kind of reevaluate our mountain.
Yeah.
So, okay, continuing on. So some of the use cases, I already talked about a couple, but fault tolerance, right? So let's say you're running, and there is I'm going to just insert this here real quick. There is a version of DMTCP that's in beta called MANA, which is, forget what it stands for, something agnostic, network agnostic. I think it's supposed to be totally agnostic version of DMTCP that can be used with MPI. And so you'd be able to use it on multiple nodes, on jobs that run on multiple nodes, which we're looking forward to. We'll probably play around with that at some point in the future too, and maybe make a video on it. But the idea is, as processes scale up, right, you've got this, a motherboard, say, has 10,000 useful hours, right? But if you're using 10,000 motherboards, the time before one of them fails, not all of them, but one of them fails, is now only maybe 100 hours, right? And so you can expect at least one failure during your runtime. So you don't want your whole job to fail just because one piece of hardware failed. And so as long as you're checkpointing your job, you can at least resume when you hit that inevitable point. And so extended sessions, this was the one that kickstarted this whole video for us. Is we have a user who wants to run a job they don't know the runtime of, but takes more than 14 days. And our runtime is 7, so we had already extended it another 7, and it still wasn't completing. So we're having to talk to them about using this software so they can run for some unknown amount of time on their data set. And so that way they'll be able to checkpoint maybe every 5 hours or every day or whatever is appropriate for their use case.
Yeah, it takes the power away from our hands and into the user's hand, where we want to be, where they can just checkpoint their own code and restart their own code in another job, and they never have to come in and ask us to either increase the time or ask us how. or any other question that they might have. They have the total control of how they want to start the job, or if there is a job that runs for more than 7 hours, they have the capability of doing that.
Right. And our job as research facilitators is to put things in our users' hands, give them the tools that they need and the education they need to be able to do it efficiently. Take away the sticking points. We are a sticking point. If you have to ask us for special requests, that's a point of friction, and we want to get rid of that. The less you have to talk to us, the better. Everybody's happy when you don't talk to us. So, and that's not meant in a mean way. That's just, our I guess I look at it as like the best thing we could ever do is put ourselves out of business, right?
Yes.
But that'll never happen, ever. Yes, so extended sessions, debugging, like I mentioned before. If you're checkpointing frequently, you can debug from the last known good state rather than waiting till it crashes and then having to rerun the whole entire job. You can rerun from that point. Reproducible bug reports, right? So if you know, hey, my process blew up, it's in your software, not my software, you can send them the checkpoint and then they can start it and go, oh, that's the memory dump. It's this function that did that, right? And so rather than having to run it for 1,000 hours themselves, they can just take it and run it for 30 seconds or however long. And then, fast startup of a process. This is a little bit of an odd one to me, but you checkpoint after it starts and then restart from the checkpoint in the future once it's started. So if you have some software that takes, I don't know, an hour to load up data and generate, whatever universe it runs in, download a bunch of files or whatever, then you could checkpoint that right after you start it and then just load from that checkpoint. And then all you're doing is reading from disk and putting into memory rather than downloading and building files or whatever is relevant. So that one's, I hadn't thought of that one. That one's a good one too. I won't go into detail on the architecture because I think that's beyond the scope of what a lot of our users care to see. If you want to, of course, you can always go to the website. We'll put the link in the video. So DMTCP is integrated with Slurm. I don't know that we don't have it as a Slurm module yet, but that might be something we could look at later. But we can use it inside of Slurm jobs as it is. You just have to add a little bit of code, and we'll show you how to do that in a minute. So we're going to go ahead and leave this one behind now. I think we've gotten the intro out of the way. So here is, let's see, my lovely VS Code environment plugged into Jihad by SSH. And so I'm looking at this tutorial that I built myself for DMTCP. And so basically I just have this task. It's, of course, a trivial toy example. And all it does is generate a bunch of random numbers. And each time it does one iteration of a for loop, it waits some random amount of time. Okay, and so the cool part about this, as we'll see, is the pseudo-random number generator state is saved along with it, and we can prove that it's loading the old state because it'll get the same random numbers again, right? And so that's how you know it's really saving your memory to disk. So let's do this.
So what's the link for this repo?
We'll put that in the video too. There's one on GitHub. I have it on GitHub and our UAB GitLab instance. They're both public. Feel free to go clone it and play with it and have fun. Give it a try.
Okay, and we should put that in the job description. So when you guys are watching the video, you should be able to
grab that from our video description. And if you have questions and you're at UAB, you can of course always email us or communicate with us. You can leave comments on videos and things like that. We're happy to. Okay, so basically, I also have a lot of documentation in this, so it'll hopefully be explanatory. So we have the usual SBatch preamble for your SBatch jobs. I assume you have a working knowledge of Slurm and how to run an SBatch job. If you don't, well, then you're going to probably have to go back to one of the earlier videos or come find us. But first, we have to, of course, load DMTCP module using the LMOD system. I'm also doing this in Python, so I need Anaconda. And then I'm going to activate my environment. And then all I do, it's very simple. I DMTCP launch, like we saw before, 5-second interval, -I, 5 seconds. And then my task that I want to run, all in quotes. So my task, so if we didn't want to do this as DMTCP, then I would just take this part, extract it, and this is what the job would look like, right? It would look like this. It would look like this instead. But because I want to be checkpointing, I just wrap it in the DMTCP launch executable. And so it's just going to call Python unbuffered, right? So we can see real time the printout on this file that I have for 100 loop iterations. So that's all it is. All right, and so we're going to run that right now. Oh. And we submitted it. So we can check our queue. Of course, it's priority. That's good. That means we're getting a lot of usage. So great. Maybe not great for this video, but great for us. We like to see it. Okay, someday it'll get going. So anyway, how's the weather while we're waiting? There it goes. Okay, it's loaded now. So I can refresh the, job.log. So go in there. It may take a second for it to get started up. Uh-oh. No, that's not good. Oh boy. All right. So do you want to pause the video here and then we can restart it?
Yeah.